Hello, good afternoon to all. Can you hear me properly? Okay, so my voice is clear to you all. Let me present my screen. Hello, my screen is visible, everyone. Okay, how's your exam? Okay, fine. So, in today's lecture, I will explain you cryptographic hash function. So I will give you the introduction regarding the what is hash function. Then after Mac, right? And then after see there are so many topics are there. Mac message authentication code, then digital signature. Then public key distribution, Kerberos. There are different topics are there. So that I will cover in this third internal. Okay, so let's start with the hash function. See, first of all, I will explain you what is hash function, and based on that, later you can understand what is the use of it. Okay, so basically, what is hash function? A hash function H that accept a variable length block of data M as an input. Some message is there. So all of you know that the message is of variable length. So what the hash function will do? Hash function H that accept a variable length block of data M as an input and produces a fixed size hash value. So produces what? Fixed size hash value. So in hash function, what happen in input? What it will take in input? It will take the variable length block of data, and what is the output of the hash function? The output of the hash function, that is fixed size hash value. It is what? Fixed size hash value, and it is also known as a digest. It is known as a what? Digest. Okay, so basically the objective what is the objective? The objective is the data integrity. So all of you know that the concept of data integrity, right? So a change in one bit or more bit in M results with a high probability in a change to hash code, right? Because here in a hash function, in input it will take what? The variable length block of data, and output, what you get in output, you get the fixed size hash value. So a change in a one bit or more bit in M, what happens? It results with a high probability in a change to a hash code, right? So a cryptographic hash function is an algorithm for which a cryptographic hash function is an algorithm for which it is computationally infeasible to find either, see the first point, the data object that map to a predefined hash result. Right, these are one-way-ness property. See, right now just understand this concept, and later I will explain you all this property so you can understand. Now please write down in the chat window, what do you mean by integrity? What do you mean by integrity? Hello, can you hear me, everyone? So please write down in the chat window, what do you mean by integrity? Can you hear me, everyone? So please write down, what do you mean by integrity? Data sent to the receiver as it is. Okay. Same over the time, no matter how many time you calculate. Okay. What about the other student? What do you mean by integrity? Okay, fine. So see, these are the two property. Later, I will explain you also in detail this property, right? So one is property, and here another is, you can say that the two data object that that map to the same hash result. That map to a what? Same hash result. That is the collision free property. Now, because of this characteristic, hash functions are often used to determine whether or not the data has changed, right? So these the two property, one-way and collision-free property. Because of this property, the hash function are often used to determine whether or not data has changed, right? Now see, this is a structure of the hash function. See here, what happened? So here some message is there, variable length message is there. Let's say this is L bits, right? So here I can say that what is P comma L? So that is the padding plus the length field, padding plus length field. So now see, whatever the variable length message is there on there, suppose let's say you can say any some hash function is there. So that hash function is applied, and when you applied the hash function, then you get some hash value, right? That is a fixed length, okay? And that is also this hash value. You can also, it is also known as a digest, right? So this is the structure of cryptographic hash function, okay? Now, what are the application of this cryptography hash function? So up to this clear everyone, what is the basic idea regarding the hash function? Yes or no? Uh, P for padding and L for length. Priyank. Hello, Priyank. Okay. So now hash function is clear everyone. What is the basic concept of hash function? Is it fine everyone? Okay. Now see, what is the next? What is the application of cryptographic hash function? So here you can say that message authentication. So it is a mechanism. It is a mechanism or service used to verify the integrity of message. See, basically, so all of you know that what do you mean by integrity, right? One or two students have given me the answer. So, what is method authentication? So, message authentication is it is one mechanism or a service to verify the integrity of a message, right? So, for that, this message authentication is used. So, in many cases, I can say that there is a requirement that the authentication mechanism assures the identity of the sender, right? So when a hash function is used to provide a message authentication, the hash value is often referred to as a message digest. Again, I repeat everyone. So message authentication, it's a one mechanism or a service. It is used to verify the integrity of the message. So in many cases, there is a requirement that the authentication mechanism that assures the identity of the sender, when a hash function is used to provide when a hash function is used to provide the message authentication, the hash value is often referred to as a message digest, right? It is often referred to as a message digest. Now see the figure everyone, so you can understand. So now see here in this figure what happened. So you have to assume there are two parties. One is a alliance and Bob, right? So first, what the alliance will do? The alliance creates a hash value, means whatever the data, whatever the message is there. original message is there on that. So what the alias will do? So it create the hash value, means some hash function is applied on this message, and on means see alias, what the alias will do? Alias create a hash value, right? So now what happened? So now once alias create a hash value, then the data, then this data means original data, and the data and the hash value, right, are sent to the Bob, are sent to a what? Bob. So again, I repeat, first of all, the messages, any data is there. What the alias will do? Alias creates a hash value. Okay, alias creates a hash value. Now then after the data and hash value, right? So data and hash value are sent to the Bob, sent to the Bob. Now upon receiving the data part, so what happened? So now see here. Upon receiving this data part, so now what the Bob will do? So Bob will again perform the hash value over it, right? Whatever the data the Bob gets, after that what the Bob will do? So again on that data, Bob perform the hash value, right? So now here, after performing this, whatever the hash value is there, it is compared with this hash value, right? So in this way, you can say that, right? So if the hash value of this data dash and the hash value of data, so that means these are hash value that is received by the Bob from allies, okay, and these are hash value computed for the received data. So now if these two values are equal, then I can say that the integrity of data is verified, right? So suppose I want to verify whatever the message is sent to from sender to receiver side, and if I want to show for integrity of data, so in that case, what you have to do? So how you can achieve the integrity? So first of all, whatever the message is there, so on that what the hash function is applied. So this on allies side. So when the hash function is applied, what you get? The some hash value you get. Now then after what happened? Data plus this hashing data plus this hashing value, right? So now it is sent it to a what? Bob, right? So now when it is sent it to a Bob, so here now what the what the receiver Bob will get? The receiver get this data plus this hashing value. Now what the Bob will do? So whatever the data is there on receiver side, again apply the hash function. So what the Bob will get? Bob get the hash value. So whatever the hash value get, so here getting over here, right? So these two hash values are compared, right? So now see this point, everyone. So these are the things that in this figure it is done. First, alias create a hash value. Now then after the data and hash value are sent it to a Bob. Now upon receiving the data part, say let's say data dash. So now what the Bob will do? Bob again perform the hash over it, right? Bob again perform the hash over it. So now after that what happened? So if the hash value of this data say data dash, that is the hash value computed for what? Received data, and the hash value received by Bob from allies. Okay, so if these two data are equal, okay, so if these two data are equal, then you can say that the integrity of data is verified. So up to this clear, everyone? Hello, is it clear to you all? Okay. So see, in this way I have explained the integrity of data is verified, right? So now the question is how the integrity of data is verified. So here I can say that if the data is received without any modification, then all of you know that. See here from allies to Bob, when the data is received, when the data is received by a Bob without any modification, then what happens? The hash value remains same. See, all of you know that how you can achieve this integrity. So here when you observe this figure, in this figure what happened? So whatever the data plus this hash value, right? So now this send it to a Bob. So now on Bob side, what the Bob will do, whatever the data the Bob getting from allies, now what the Bob will do, again performing the hash function, and these two hash values are compared. So if these two values are compared, that means you can say that the integrity is achieved. But see, here you can say that, let's say the data is changed. So when the data is changed, then what happened? So here, so at that time, what happened? The hash values are different. Yes or no? Right? So that means, see here. So here I can say that if the data is received without any modification to above, then what happens? The hash value will remain same. Otherwise, what happens? The S data is not equals to H data dash, right? So that means I can say that then the data dash means received data. Data dash means received data has been modified and that indicate the violation of integrity, right, has been modified and it indicates that it is a violation of integrity. So the figure 1 is clear to you all. Is there any need to explain it again? Is it clear everyone? Any doubt? Okay. So I think it is clear to you all, right? So now I will explain you the second figure. Just wait. Just wait everyone. Okay, fine. So now the next figure, that is figure number 2. Now what the figure number 2 says, the attack against a hash function. Okay. So in the previous figure, I have explained you about the how the integrity can be achieved. Now in the second figure, what happened? The attack against the hash function. So now, see here in this case, what happened? We can say that if an adversary EU means it's an attacker, right? So in this figure, what you observe, the attacker, right? It changes the data to data dash. The what the attacker will do? So now see here what happened. Initially, some data is there, right? Now let's say the hash function is applied. So when the hash function is applied, so what you get? So the data plus the here what you get, this some hash value of this data you are getting, right? So this thing that you are getting. So now when it is sent it to a Bob, so at that time, suppose let's say some attacker come. Okay, so when the attacker come, what the attacker will do? Then attacker get this data plus this hash value. Okay, now let's say here I can say that now once the attacker get anyhow the so let's say the attacker get this data. Okay, so now the attacker if changes the data to data dash, whatever the original data is there, what the attacker will do? It will change it to the data dash, and again on this data dash, what the attacker will do? Apply the hash function and then get the hash value. So again you get what the data plus hash value that the attacker will get. Now after that what happened? So now again it is sent it to a bomb, right? So by what attacker? So here you can say that in this way the if the attacker can fool the bomb, because what happened? See here how the attacker fool the bomb, because all of you know that when the data is sent it over here, so at that time what happened? So here on Bob side, what the Bob will get, data plus this hash value, this thing the Bob receiver will get. So now what happened? So on this data dash, again the hash function is applied. So what you get, hash value. So here already there's some hash value is there. So this hash value, and on this data dash, again the hash function is applied. So you get this hash value. So here you can say that here the both the hash values are compared, right? So that means you can say that the you can fool the Bob because the Bob will verify the hash value, it will be compare, will produce true. All of you know that. And this way the you can fool the Bob, because what happened, because here basically the purpose is what, the allies want to send a message. See, the allies want to send this message data to a Bob, right? But here in this case what happened, so whatever the data is there, first of all, by applying the hash function you are getting hash value. So this data plus hash value, that is send it to a Bob. But when send it to a Bob, so at that time some attacker come in the picture, right? Some attacker come, and what the attacker will do, whatever the data is there, right? So now it changes this data to a data dash. Okay, so now again on this data dash what happened, again the hash function is applied, right? So here what you get, data dash plus hash value. So now this data plus hash value, so now what, now you actually allies want to send this to a Bob, but some attacker come, and now attacker modify the data, and now that modified data is sent it to a Bob. But see, but the Bob what happened, but actually Bob what it will do, so the what the Bob will do, so Bob here apply the hash function, so here get the hash value, and these two hash values are compared. So that means it is so both are compared, so true. So Bob feel that I am getting the message from allies, but see actually it is coming from what, EU. So here you can say that in this way the EU can fool the Bob. So all of you clear? Hello, is it clear to you all, the second number figure? Uh, Antrip, so please can you unmute yourself? What you are trying to say, please unmute yourself.
Ma'am, here data we are passing and the hash value we are passing. So if you gets the data and if the data is in plain text, then he won't get the original message.
Hello.
Hello.
Yes, I'm not getting your Sunai. Hello, please repeat it again.
Ma'am, we are passing data and the hash value generated by the hash function to
So in
the
this,
receiver.
see the message in this form, and also the hash value is also in this form. See here.
Okay.
Now fine.
Yes, ma'am.
Okay, that's why I have shown you this example. Now, is it clear to you all? Antri?
Yes, ma'am.
Okay, fine. Okay, so now up to this, I think all of you, is it clear to you all? So actually, Alice want to send the message, but basically what happened? But the Bob, it is received by Eve. So in this way, the Eve can pull the Bob, right? So now the question arises in your mind, that is how to prevent this thing, right? How to prevent this thing? So here I can say that the hash value generated by Alice. Now see here. Here, whatever the hash value generated by allies, that must be what? That must be protected. Okay. So here the next concept is, see in the second number figure what happened. So here you can say that this type of question is arise. So if you want to prevent this, so for that what you have to do, whatever the hash value that is generated by allies, that must be protected, right? So now this is the figure number 3. So in figure number 3, what happened? Sorry. So in this figure number 3, what happened? It illustrates the variety of ways in which the hash code can be used to provide a message authentication. A hash code can be used to provide a message authentication as follows. So how the hash code can be used to provide a message authentication? Okay. So now see here the figure. See, up till now, what we have, up till now, what is the concept? Whatever the message is there, whatever the data is there, on that the hash function is applied. So what you get the hash value. So this data plus this hash data, right? So now it is sent it to it is sent, right? So now, so in that case, you can say that this type of problem is occur. So if you want to prevent it, so for that, what you have to do? So here you can say that whatever the message, so the message plus concatenated message plus concatenated hash code, it is encrypted by symmetric encryption. It is encrypted by what? So it is encrypted using a symmetric encryption. See, all of you know that there is a sad key between the two party, both Alice and Bob. So in each and every scenario, you have to assume, here I have written source A and B. So here you have to assume there is a sender and there is a receiver, right? So here you can say that there is a shared key between this what both the party A and B. Okay, you have to assume in that way. So now in this scenario, what happened? The message plus the concatenated hash code. The concatenated hash code is encrypted using the symmetric encryption. So by using this key, it is encrypted. So now here, what you get? This what which thing you get? So here you can say that the message. See here, here it's a concatenation. This is the message, or another thing is what? It's a whatever the message is there, right? So see on this, first of all, see here in this particular phase, what happened? Whatever the original message is there, on that hash value is applied. So what you get? This hm you get, right? So now this hm and this original m, so both are what? Concatenated. So these two things, original plus hash code, right? So this concatenated, right? On that, what? This and here the encryption is done by using the key, right? So this thing is done by sender. Now which thing is done by receiver? So all of you know that because the A and B shared the secret key, right? So here you can say that the message must have come from A and has not been altered, right? So that's why here you can say that because the encryption is applied to the entire message plus hash code, you can say that the confidentiality is achieved. Again, I repeat everyone. So here in this case, what happened? The message plus concatenated hash code, it is encrypted by using the symmetric encryption, right? So this thing is done on sender side. On receiver side, what happened? So you get this thing. So now what happened? So now decrypted, all of you know that both the party know the secret key. So by using this key, now it is decrypted. So when it is decrypted, so what you get? The message plus hash code that you are getting, right? So now here, now again, whatever the message is there, on that hashing is a hash function is applied. So now what happened? So here you are getting some hash data. So now in this first apply the hash function, right? And so what you get? Some hash value that you are getting. So now both the hash values are compared. Both the hash values are compared. So now in this way, you can say that the confidentiality is achieved. So what do you mean by confidentiality? Is it clear to you all? Prince, you are saying about confidentiality? Hello? Okay, good. Ensure that the information are accessed only by an authorized person, right? So by by this particular figure, you can say that the confidentiality is achieved. So see, again I repeat how the confidentiality is achieved. So here in this case, what happened, whatever the message is there, also message, so on that the hashing is applied. So here what you get, the hash value that you are getting, so this message plus concreted hash code, right, it is encrypted by using a what, using a symmetric encryption. So now when the message plus the hash code, so now see here in this case what happened, so here no encryption is done. So that's why what happened, so because of that what happened, let's say the attacker that come in picture and get the this data value. But here in this scenario what happened, so whatever the message plus hash code is there, now it is encrypted. And all of you know that, see, Alice and Bob, both the party only know this secret key, right? So that's why it's not possible for see here you can say that the attacker can't take this value, right? Because it is encrypted, right? Only it is decrypted by what? So this particular you can say that only it is decrypted by receiver only, because both the party know this shared secret key, right? So this thing is done on client side. On receiver side, what happened? Whatever the message plus this hash code, right? So here the decryption algorithm is applied. Right now, here shared key is there. So now when it is decrypted, what you get, the message plus this hash code that you are getting. So now again what happened, whatever the message is there, again on that hash function is applied. So what you get, the hash code that you are getting. So this hash code and this hash code, both are compared. So when both are compared, then you can say that the confidentiality is achieved. All of you clear? Is there any doubt? Is it clear to you all up to this? Is there any doubt? Is there any doubt, everyone? So here you can say that that is DES or AES. I think in symmetric you study this particular topic. So DES or AES like algorithm is used. D, that is DES or AES like decryption algorithm is used, and K is the secret key. So now by using this figure, see, right now I have explained you this, right? So now by using this figure, what can you achieve? So now see here. So these are the two goals that are achieved by using this figure. So the first, that is confidentiality. Why? Because the M is encrypted using the key K by using a symmetric cipher, right? So the message is encrypted by using the key by symmetric cipher. So here you can say that here in this figure you can say that the confidentiality is achieved, right? The confidentiality is achieved. Now, authentication of message. So we can verify that the source is A as after decryption using the shared secret key, right? So the comparison returns true. So again, I repeat, we can verify that. What we can verify? So we can verify that the source is A as after decryption using shared secret key K. The comparison returns true. See, this comparison is returned true, right? So then you can say that hash values are same. Then you can say that the authentication is achieved. So these are the two goals that are achieved by using this figure: confidentiality and authentication. Is it clear to you all? Hello? Can you hear me, everyone? So it's fine up to this, everyone. Anyone ever doubt? The PS means any doubt? Okay, fine. Okay, now see the B number figure. So now see these are the different scenarios are there. See in this figure what I have done. So what is that here? The message plus concatenated hash code, right? Now it is encrypted. Here what you get? The message plus hash code, right? So these two are concatenated, and after that you can say that it is encrypted by using the key. Okay, it is encrypted by using the key. Now here in this case, here, what about this figure? So here what happened? Here when you observe this figure, then you can say that now in this scenario only the hash code is encrypted using the symmetric encryption. So this reduces the processing burden for those applications that do not require confidentiality. Now listen. So if you want the confidentiality as well as the authentication, then you can say that, see, at that time this mechanism is used, right? First, what happened? The message plus hash code is this concreted hash code is encrypted by using a what? Symmetric encryption. Okay. So here you can say that, see, here in this particular scenario, the whatever the hash code is there, it is encrypted by using a symmetric encryption. So in this way, it reduces the processing burden for those applications that do not require the confidentiality, right? So now see, when you observe the figure, how it works, can anyone explain me? Deep, can you unmute yourself? Hello, can you hear me? Deep?
Yes, ma'am.
Yes, can you explain this B figure, how it works?
Ma'am, your screen is stuck, not visible. Your
It's not
screen is
visible?
stuck at, yes, yes. Ma'am.
Just wait, again I will share. Now it's visible, Deep?
No,
Hello,
ma'am. No, ma'am.
all of you? Jenny, it's not visible? Okay, let me check my network. Just wait. Just wait, I will check my connection. Now it's visible. Okay, see, ક્યારથી નથી દેખાતી સ્ક્રીન? દીપ, હમણાં જ બંધ થઈ કે ક્યારની નથી દેખાતી?
No, ma'am. You started explaining figure B.
Okay,
on
okay,
that
fine.
part.
Okay, so now can you explain how it works? See, already the A figure, all A figure that I have explained, like how exactly the working is done. From the figure, you can also explain, right?
Yes, ma'am. First of all, data and its encrypted hash value is concatenated. Then it is given to the encryption part, and after that, it is given to the receiver B. and
Okay.
it's comparing the hash value and the decrypted part, and that's how it works. And comparing that is the same. We can say our goal is achieved.
So which goal is achieved here?
Confidentiality.
Okay, Janil, can you hear me? Hello? Yes. Janil, can you unmute yourself and please explain me how the B number figure is work again in proper way? Janil, can you hear me? Hello?
Yes, ma'am. Can you hear me?
Yes, yes.
Yes, ma'am. When, we have a message on ally side, then we uh, ha- create the hash value of it. Then we encrypt the hash value and combine it with message and send it to receiver. Then we compare hash value of message and decrypt the encrypted hash value given by Alice, and we compare the hash value, and if it is matching, then our message is not tempered.
Okay. So which goal you achieve here? Here only the hash value here whatever the hash code is there that is encrypted, right?
Yes, ma'am.
Right. So which goal is achieved?
If message was like changed, then we can means we can come to know that message was tempered.
Okay, fine, Janil. So here in figure number B, you can say that only the hash code is encrypted by using a symmetric encryption, right? So it reduces the processing burden for those applications that do not require the confidentiality. Now, when you see, now observe the C number figure. So now in this technique, what happened? So here in this case, when you observe here, so assume that the two communicating party that share a common secret value S. Just wait, everyone. With a lecture. sorry. Uh, Okay, now when you see this third figure, so now in this figure, what happened? This technique assumed that the two communicating party that share a common secret value s, right? So here you can say that a computer hash value over a over you can say that the concatenation of what m and s. Okay, so concatenation of m and s, what happened, so here you can say that whatever the concatenation of m and s is there over the it compute the hash value. Okay, and then append this resulting hash value with this s. Okay, so now here in this case you can say that on the receiver side what the receiver will get, so the message plus you can say that the message sorry, the message in the message plus has what hash code. So now see this concatenation is getting, so now on receiver side what happened, what the receiver will do, so on this m apply this as value, so apply this shared secret key, because both the party that share a common secret key, right? And now again on this concatenation again apply the hash code, and then after what happened, this code and this hash code, it is compare. So when it is compare, right, so here you can say that this option C, that you see the hash function but no encryption for message authentication. Clear everyone, right? So now here you can say that if you try to modify the m, then the comparison of hash values will be failed. So here you can say that this does not include the confidentiality aspects. Now what about the this figure, so here you can say that, so this part. So now see, what is the difference between this thing? So here you can say that here in this case only the hash code is encrypted, right? Now here in this figure what happened? Whatever the message plus this shared key is there. So now this concatenation on that what the hashing is applied, and what you get the hash code is hash code that you are only means hash code that you are getting, right? And hash value over this concatenation m and s, and then appending this result to this m, right? This thing is done. Now what about this d figure? So now here what happened, whatever the message is there, so now whatever the message is there, the message plus this secret key, now it is concatenated. So now over you can say that the hash value over this concatenation m and s, right? Now again what happened, so again and appending this hash value this to this m, and again on that what the encryption is done, where this by using this symmetric key. Okay, so now finally what you get here, so the message plus the message plus what this message plus this hash value. Okay, so and see means this encrypted message you are getting. So now what about this receiver side? So receiver side, the receiver perform this decryption by it, because both the party know the shared key, right? Again, so when you decrypt it, so you get this part, right? So now what happened, so this m and this the hash value. So again on that what happened, again on that you can say that the shared key is applied. So now so here you get the concatenated concatenated concatenation, right, of m and s that you are getting. Again on that some hash function is applied, so you get the h value. So this h value and this h value both are compared, so when it is true, right? So this achieves, by using this figure you can say that it achieves the message authentication and confidentiality, right? So the MAC, that is message authentication code, and it is also known as a keyed hash function. So up to this clear everyone? Is there any doubt? Hello? Is it clear to you all? Please reply so I can understand. Hello, can you hear me? Hello, is it clear to you all? Can I explain you this all figure in next class again? It's not clear to you all? Please reply so I can understand. Can I explain it again in next lecture? Okay, fine. Okay, I will explain you in next class also. So now see here everyone. So what is MAC? MAC, it's a combination of hash plus symmetric encryption, right? So basically what's the difference between this MAC and hash? So I see basically the hash functions are used to guarantee the integrity of data while the MAC that guarantee the integrity and authentication. Okay. So Mac uses a private key, that is the secret key, while the hash does not use any key, right? So these are the difference between Mac and hash that you have to keep in mind. Now, all of you know that this thing already that I have explained. So this thing is done in Mac. So whatever the message is there, on that the hashing is applied, right? So what you get, hash code that you are getting, after that it is encrypted by using some key, right? That is shared by both the party. So here you get the message plus the encrypted this hash code, right? Now on receiver side, what happened? So on receiver side, the message plus the encrypted hash code is there. So now on the again in message, hash function is applied. So what you get, the hash value that you are getting, and here you can say that here in this case what happened. So now here it is decrypted by using some key. So you get HM and both these hash values are compared. So finally you can say that the integrity is achieved. So if this comparison is true, then it return true. The sender is verified and authorized as a key. K is only with the allies, right? So if this comparison is false, then you can say that the message M is modified by an attacker, right? So this is all about Mac everyone. So is it clear to you all? Hello? Now it's clear everyone? So I will explain you the digital signature in next class. Again, see, in again I will give you a quick overview, right, regarding this figure. Okay, in next class again, quickly we will revise that thing, and then after in next lecture I will explain you the digital signature. Okay, fine, everyone. Thank you. So the next topic will start from I think the Thursday or Wednesday we have a lecture, right? So at that time I will explain. Thank you.